So, this past weekend in Austin, Texas, Elon Musk dropped what might be his most audacious venture yet. And that is really saying something. It's called Terafab, and it's being built as an AI factory in space. Yeah, it's a plan that pretty much redefines the word ambition. Musk himself kicked things off by calling it, and I quote, the most epic chip-building exercise in history by far. Now, that's not just hype. Terafab is this massive joint venture between Tesla, SpaceX, and xAI, and it's designed to do something that sounds almost impossible. All right, so let's get into this most epic announcement. What are we really talking about here? Well, for starters, it's a $25 billion bet on the future of AI. But this isn't just about building another factory. No, this is a full-on attempt to completely rewire the entire global semiconductor industry. So what is Terafab exactly? The plan is for a completely vertically integrated facility. What that means is everything from designing the chip to actually making it to testing it. It all happens under one single gigantic roof. Trust me, this kind of end-to-end production just hasn't been done before at this kind of scale. And to really get a sense of the ambition, just look at these numbers. The entire world's AI compute output right now is about 20 gigawatts. Terafab's goal? To produce 1 terawatt annually. That is 50 times the current global output from a single project. The numbers are just absolutely staggering. Now, to house that kind of ambition, you need a building that's almost impossible to imagine. We're talking 100 million square feet. To put that into perspective for you, that's the size of about 15 pentagons, or 3 central parks. It's so unbelievably big that Musk confirmed it won't even fit on the already massive Gigafactory Texas campus. So you have to ask, why? Why attempt something this monumental? Well, according to Musk, it's not really a choice. He says he's getting ready for a coming chip crisis, a future where the only option is to just build it all yourself. And the core of his argument is this. He believes we're facing an explosive, almost insatiable demand for AI hardware. And the big problem, the bottleneck, is that the current suppliers, the giants like TSMC and Samsung, they're great, but they just can't expand fast enough to keep up. So in his mind, building this in-house isn't a strategic choice. It's an absolute necessity. He put it about as bluntly as you can. We either build the Terafab or we don't have the chips, and we need the chips, so we build the Terafab. You can see how this frames the whole project, not as some grand opportunity, but really as an act of survival for his company's biggest goals. Terafab is actually going to be producing 2 totally different lines of chips. First, you've got the terrestrial chips, the AI5 and AI6 processors. Those are for Tesla's cars and its Optimus robots. But then you have the orbital chips. These are hardened D3 processors built specifically to survive the incredibly harsh environment of outer space. And this is where the story takes a turn. This is the truly unprecedented part of the plan, where we go from a really ambitious project on Earth to something that sounds like it's straight out of science fiction. Because if you ask Musk, the future of AI isn't here, it's in space. Which, of course, brings up a pretty big question. If you're creating this incomprehensible amount of computing power, where is it all supposed to go? And the answer is just stunning. A full 80% of Terafab's output is planned for orbital use. Only 20% will actually be used down here on Earth for the cars and the robots. The vast, vast majority is headed for low Earth orbit. Okay, so why on Earth, or maybe off of it, would you do this? Well, the engineering logic is actually really compelling. In space, you get 5 times more solar power because there's no night, no clouds. Getting rid of all that waste heat from the chips is way more efficient in a vacuum. And you're completely free from the limits of our power grids back on Earth. And just in case you're thinking this is all just some crazy theory, well, this is the official FCC filing from SpaceX for its orbital data center system. They are literally asking for permission to launch and operate a constellation of up to 1 million satellites. So yeah, this is a very real, very serious engineering plan. And what all this really reveals is that Terafab isn't just about making chips. No, it's the final missing piece of the puzzle, the thing that's designed to unite Musk's entire ecosystem of companies.
And when you look at it, the logic is kind of seamless. Step 1, Terafab builds the AI chips down here on Earth. Step 2, Tesla uses some of them in its cars and robots. Step 3, SpaceX launches the rest of them into orbit. And Step 4, xAI runs its huge AI models on those chips in space. It's the definition of complete vertical integration.
And that's exactly why Musk himself called Terafab the final missing piece of the puzzle. It's the linchpin. It's what connects his car company, his robot company, his space company, and his AI company into one single coherent vision. But, a plan this huge is obviously going to have its skeptics. And that brings us to the trillion-dollar question mark. It's time for a pretty sober reality check on this whole thing. Industry analysts were, let's say, quick to point out some monumental hurdles. We're talking about the insane cost and complexity, the fact that none of Musk's companies have any real experience in high-volume chip manufacturing, the incredibly long wait times for the specialized equipment you need, and, let's be honest, Musk's own history of missing some very ambitious deadlines on projects like full self-driving. And this really shows you the two sides of the coin. On one hand, you've got Musk's grand vision of Terafab as the final missing piece, and on the other, you have this very cautious skepticism from analysts. You see Barclays calling it a show-me story that feels like a stretch. Basically, they want to see the proof before they'll believe it. And, in the end, it might just come down to the money. Some high-end analyst estimates suggest that to actually realize the full 1 terawatt vision, the capital required could be as high as $13 trillion. That's a number that's almost hard to even process. It's basically the cost of the entire global semiconductor industry as it exists today. So that leaves us with the big question. Is Terafab an impossible multi-trillion-dollar dream? Or is it the necessary, absolutely audacious blueprint for humanity's multi-planetary future? I guess only time will tell.